Greetings everybody. It is another very cold day in my unheated office where today it's at 61 degrees in the office. I have to admit I'm getting a little tired of it at this point. But anyway, let's talk today about solving exponential equations, which are equations that where the unknown, the thing you're trying to solve for, the x or whatever it is in the exponent somehow. Like this one says 27 to the power 1/3 times x. That's an exponential equation. But the issue that I want to discuss about it is, does it matter if I use ln, the natural logarithm, or log, the common logarithm? Okay, is it going to make any difference at all? Now, ln is logarithm base number e, and log, the common logarithm, is a logarithm base number 10. But all logarithms are treated exactly the same way no matter what the base is. Okay, now the reason why I want to address this question is because you might see something like this on your assignment, where it says solve the following exponential equation, and then over here where we would put the answer in, it says something like this: use ln for natural logarithm and log for common logarithms. Okay, as if maybe like it doesn't matter, or maybe you have to decide which one to use. Okay, but the answer to that question, does it matter, is that it does not matter. That's the short answer. It makes no difference. Any exponential equation you can solve with one logarithm, you can solve with any of them. It makes no difference. Any logarithm can be used as long as your calculator has a function for that logarithm. What the logarithm allows us to do is use a calculator to get the ultimate answer. So you can use any logarithm that your calculator has the capability of calculating. Okay, and a scientific calculator typically can do natural logarithms and common logarithms. So that's why those are the ones we typically use. But don't mix them up. Like, pick whichever one you're going to use and use it. All right, other than that, it doesn't matter. But if I'm going to make the video, I'm going to show you an example, and I'm going to mention what about logarithms allows us to solve these equations. There is a property of logarithms that looks like this, that says a logarithm of any base of something raised to some power is the same thing as that power times the logarithm. So we get to move the exponent, we get to move the power. That's why we use logarithms to solve exponential equations. Okay, but I was going to make the point to you that it doesn't matter what logarithm you use. Okay, so let's look at an example. Here's an example that's similar to this one. Not exactly the same, but it is similar. It says solve 27 to the power 1/3 times x is equal to 9. What does that x need to be for this equation to be true? Alright, so however we're going to do it, let's say with the natural logarithm, we apply that logarithm to each side. Why are we allowed to do that? Well, an equation is like a balanced scale, and you can do something to one side as long as you do the same thing to the other side. Okay, so if I want to take the logarithm of one side, I have to take the logarithm of the other side. Now we'll keep it balanced if you do the same thing to each side. Okay, that's also why I said that you can use any logarithm you want to solve these equations. Just don't mix them up, because if you used one on one side and then a different one on the other side, then you would unbalance the scale. You'd be doing different things on each side. Anyway, so why would we start with that step? Well, because that property of logarithms allows us to move that power. Okay, because as it is in this equation, the thing we're trying to solve for, the x, I want to know, what is this x supposed to be? What's that number? It's stuck at the exponent position. I can't just take it and put it somewhere else. It's stuck there. But the logarithm and this property right here allows me to move it. So I moved it, now it's right there. And I want to solve for the x. So what I did at this point is I multiplied both sides by 3, I guess you could say. Okay, Why would I do that? Because I canceled the 1/3. Okay, the 3 shows up over there. And then to solve all the way for the x, I divide by natural log 27. And so I get my answer as 3 times natural log 9 divided by natural log 27. And then we use our calculator, and it tells us that that's 2. Okay, 2 is the answer. All right, now, it doesn't matter which one you use, though. You can use any logarithm you want. You can use the natural or common, makes no difference. So try it out if you want to. Here, I'll solve this equation exactly the same way, but I'll use the common logarithm. Okay? So I take the common logarithm on each side, I move the exponent, I multiply by 3, I divide by common logarithm log 27, and I calculate and I still get 2, right? I mean, it's going to come to that point, you know, either here or here where I use my calculator. I'll show you on the calculator I typically use. I have a button. This is hard to do. Let's see. This is very hard to do. There they are. Right there. They're blurry. But there's common and natural logarithms right above my index finger. They're out of focus, but oh well, that's the best I can do. So that's how I would calculate those. All right. See, doesn't matter. It makes no difference. I got the same answer. I got 2, and it's the right answer either way. But, you know, you might have a calculator that will calculate a logarithm of any base. You know, this calculator here just does base 10 and base e, common and natural logarithms. But, like, you see the pattern here? Like, this is how the answer ends up, no matter what, with the logarithms. So, like, say you use logarithm base 12. Would that make a difference? Would that matter? Okay? I mean, no matter what logarithm you throw in this step, you move the exponent and you go through the motions the same way. It shouldn't make any difference. So, if your calculator can do a base 12 logarithm, then this should work and it should give me the same answer. I happen to have a calculator that does base 12 or any base you want. So, see this one, there it is. See what I typed in there? 3 log base 12 of 9, okay? And I'm going to divide that by log base 12 of 27. Okay, so see I typed in, like, this calculator will do logarithms of any base that I want. And so we're just going to use base 12 as an experiment to see what happens. To show you it doesn't matter, look what it gave me. It still tells me 2. So it doesn't make any difference. You can use any logarithm you want. Just be consistent about it, and just use one that your calculator has the capability for.